Hello, this is David Quantrill and Nigel Evans of Canham Consulting. We would like to talk briefly about a project that we have recently been involved in at Cromer Parish Church, which at 160 feet and 4 inches is the tallest church tower in Norfolk. The bell chamber at the top of the tower contains 6 bells, ranging in size, with the 2 largest weighing over half a tonne each. The oldest bell is medieval, dating from 1450 and is subject to a preservation order. The remaining 5 bells are later additions from 1874. Our brief was to design a temporary scaffold within the bell chamber that would permit the safe removal and reinstatement of the bells internally through a high-level opening within the tower. We wished to demonstrate the design methods used, particularly the use of 3D modelling software to help us contribute to the successful completion of this project. Initially, it was necessary to carry out a survey of the bell chamber and to understand how the scaffold was to be used. When designing a scaffold, as with any structure, it is important to understand the end user's requirements and limitations in order to fulfil the brief. This then allowed us to carry out structural calculations and work up a conceptual scheme. This was then taken and modelled by Nigel using the 3D modelling software Tekla. Nigel will now give us a quick run-through of the process.
Tekla allows us to model in 3D any structural form. So in this particular instance, I took David's initial conceptual hand-drawn isometric sketch and used that as the basis to create the 3D model. This 3D model can then be taken to the client and used as a tool to illustrate what we want to achieve. This model allowed us to show the intricate connections required to ensure the stability of the scaffold far more effectively than a traditional 2D drawing would have done.
It was necessary for the scaffold to be not only versatile and strong, but also to be as light and simple as possible, as all of the components had to be brought up the tower either via the narrow spiral staircase or by hand pulling through the high-level hatch. And in addition, the scaffold itself had to be constructed in a confined space above the bells and framework.
The output from Tekla can be given to the client in a number of different formats: the traditional paper copy or as a web page so that the model can be viewed through Internet Explorer. The web viewer allows the client to fly around the model and to zoom in on areas of interest and to interrogate the model with a far greater level of detail than a paper drawing would allow. We're also able to produce a model which can be viewed through Tekla's bespoke software called BIMsite, which is free to download from the Tekla website. This allows the client a greater level of interrogation than the web viewer, and we found this format in particular to be a very useful way of illustrating our design philosophy to contractors and members of the design team.
I'm pleased to report that in both construction and operation, the scaffold proved highly successful. The entire scaffold was built without a hitch in a couple of days. Then the 150-year-old bolts were pulled from the timber bell frames using a block and tackle attached to the aluminium unit beams to release the bells. These were then lowered on chains one by one down the inside of the tower. We can see here the final and largest number 6 bell being gently lowered. It was rather an eerie sight seeing something not only so large and heavy, but also built to make a lot of noise, hanging silently in space. Once the final tricky manoeuvring was complete, and the largest bell had barely squeezed through the gallery hatch, all bells were successfully back on terra firma. During the entire lifting process, I'm reliably informed that not the slightest creak of complaint could be heard from the scaffold. The bells were then taken outside to be loaded and transported to their next destination, where they would be fitted with new headstocks and retuned, before being returned to be lifted back into place with their 2 new companions. In summary, this was an interesting and enjoyable project to work on. The use of 3D modelling helped to ensure that the temporary works were easily understood and constructed in accordance with the design. 21st century technology helping to ensure that the medieval bell and its companions will ring for years to come.